Swayam Prabha. Digital India. Educated India.
Welcome to Module I, Lecture 4. In this lecture, we shall discuss about crash data analysis. In Lecture 3, we discussed about black spots, how we can define black spot or what is really black spot, and then different techniques for identification of black spot, for example, crash frequency method, then fatal crash frequency method, equivalent property damage only method, upper tail critical test, and then with some example data I have also shown you how you can identify black spot. Now, the data is there. So, we want to do the analysis of the crash data. So, first the crash data representation. We may represent crash data using a number of meaningful basic parameters. For example, crash rate, a very important parameter. It may indicate number of crashes of all types per kilometer length of road. So, you have so many hundreds and thousands of kilometers of road, and you take different sections and then decide how many number of crashes are happening or have occurred per kilometer length of the road. Second, it could also be expressed in terms of number of crashes per million vehicle, typically for intersections. How many vehicles are using the intersections? So, per million vehicles how many crashes are happening. Third, number of crashes per million vehicle kilometer of travel, and typically for segments this is a meaningful expression. So, crash rate could all be expressed in terms of all these three possibilities. First, number of crash per kilometer length of road, or per million vehicles, or per million vehicle kilometer travel. You have to take a suitable quantification as per the context. Given a context, what is more meaningful? Second, next important basic parameter may be the traffic exposure. I can express it in terms of total number of vehicles entering a spot during a period. That period may be 1 hour, 1 year, 2 year, 3 year. So, how many total number of vehicles are entering a spot during a given period? Also it could be expressed exposure in terms of total vehicle kilometer travel over the section during a period. You have taken a section, then during a period, considering that overall section, what is the total vehicle kilometer travel that has occurred. So, if we are expressing traffic exposure in terms of total number of vehicles entering a spot during a period, then it can be expressed like this: entering vehicles in millions. So, you have ADT, average daily traffic, or AADT, annual average daily traffic, multiplied by 365, that is the yearly traffic, multiplied by the number of years we are considering, divided by 1 million or 10 lakhs in Indian context, right. So, I have written it like million. So, I have used the commas in that manner. If I am going for the second one, that means total vehicle kilometer travel over the section during a period. So, I can again express it vehicle kilometer, instead of that million vehicle kilometer travel. So, then again ADT or ADT multiplied by 365 into years into kilometer over the section, how much kilometer, divided by 1 million, that gives you the million vehicle kilometer travel. So, that shows you how we can quantify the traffic exposure. Now, I will show you, once you have quantified the traffic exposure, how you can calculate the crash rate. So, the crash rate for a location may be found by dividing the crash experience by the exposure, number of crashes divided by exposure, because what is the rate? It is basically crash rate, right. So, number of crashes divided by traffic exposure. So, exposure we will use if we want, suppose number of crash per kilometer length of road, then one way we will do number of crashes per million vehicle, if we want we will do accordingly. So, but all cases basically the crash rate is number of crashes divided by exposure. So, for a spot or maybe 500 meter or less in length of the road stretch, the crash rate can be expressed as number of crashes for the study period total divided by the exposure. Exposure is what? ADT into 365 into years divided by 1 million. So, 1 million will come here. So, that way you can express the spot crash rate. For section, typically as we said, or segments, it is million vehicle kilometer, right. So, how you can express number of crashes for the study period divided by ADT into 365 into kilometer into years divided by 1 million, right. So, here you will get section crash rate, and in what? Vehicle crash, number of crashes per million vehicle kilometer of travel. So, this is the expression, and the first one, rather the middle one, is number of crashes per million vehicle, that is all. Now, the third meaningful parameter, as we have said earlier, crash rate, then traffic exposure, then third meaningful parameter is crash involvement rate. What is that? It is that number of drivers of vehicles with certain characteristics. Please note that we are saying number of drivers of vehicles with certain characteristics who were involved in crashes per 100 million vehicle kilometer of travel. So, how to express crash involvement rate? Take that number of drivers of vehicles involved in crashes during the period divided by vehicle kilometer travelled during that period, and since we said per 100 million vehicle kilometer. So, divided by 100 million. So, that is what is written. Okay. So, that is what it is. Now, the death rate is the traffic hazard to life in a community and is expressed as number of fatalities per 100,000 population. Per 100,000 population, how many fatalities is happened or has happened? How many fatalities is happening per 100,000 population, or how many fatalities has happened per 100,000 population? So, it reflects the crash exposure for the entire area people are living. So, you It is very important, very meaningful measure. So, how we can get it? Death rate, number of traffic deaths per year into or divided by basically population of the area, but then we are expressing it per 100,000 population. So, it is multiplied by 100,000. That is the death rate. Let us take an example. Suppose you have 5 locations or short stretch or segment, whatever you say. Section lengths are given, different section length, different ADT value, different number of crashes and different study periods. But then how I compare? How I compare? These are the meaningful parameters, basic parameters. They can help us to do a meaningful comparison. So, let us go ahead. Location is given, section length is given, ADT is given, number of crashes is given, study period is also given. So, I am now calculating the crash frequency. What is crash frequency? Number of crash per kilometer per year. So, you take the crash, number of crashes 19 divided by per kilometer. So, divided by 1.5 per year 3.25 is the period. So, divided by 3.25. So, that is what you get 3.9. So, now I have kind of normalized it, expressed it in terms of crash per kilometer per year. So, like that the quantities you calculate and you find here location B that has got the highest value of crash frequency, right. So, we can identify that segment or the location. Similarly, I can also calculate the crash rate, crash per million vehicle kilometer travel. So, 19 crash divided by million vehicle kilometer travel, 365 number of days in a year, 3.25 year multiplied by 3600 ADT into section length is 1.5. So, you calculate it 2.97. Like that you calculate for all the sections and you find here section C has got the highest crash rate 4.96. So, like that we can identify the sections when sections have different length, different ADT, different number of crashes, different study periods, right, but still we can compare them and different parameters like the crash frequency wise some section may be worse, crash rate wise some other section may be the worst. Sometimes it may be the same section telling you that that should be your focus, immediate focus. So, it helps us to compare different sections with different numbers of accidents or crashes, different study period, length of the road, traffic volume is different. So, we can still compare them in a meaningful manner. Now, we go to the next part, that is crash data modeling. There are different approaches. We shall briefly mention to you about two major approaches, statistical methods and then soft computing methods. Obviously, I have some difficulty here because I cannot go into details, because any modeling approach if I want to discuss in details, that will take a good amount of time, and if you do not have the background it is very difficult. But I wanted to tell you that you can actually use very well use statistical methods, different modeling approaches, statistical model you can develop. You can also use soft computing techniques ML based technique, machine learning based techniques, models to do the crash data modeling very meaningfully. So, it is little bit only some overall understanding or ideas, not really going into details, because if you know every type of model, it may, if I want to explain you how to do the models, how to develop a model, it will take really a lot of time. So, just a quick overview. Statistical methods, using statistical methods, I can model the crash frequency. You can also say, or we also call these models at count data models, because the number, we are talking about the crash frequencies, the number of crashes, right. So, these are count data models. So, I can actually develop count data models. For example, you may use Poisson model or negative binomial, right, and through development of safety performance functions, SPFs. You want to know more, you have to further follow other lectures probably, or take some other course where you can learn more. And I am almost towards the end, this is the last module of this course. So, I want to touch upon some of the things, that how the, in which way we are proceeding, or which way the world is going actually. So, everything I will not be able to tell you in details, but give you some ideas which way the things are moving. So, here you can model crash frequency using count data model through the development of safety performance function, SPF. Now, these SPFs one way are very useful, because they can help us to identify factors causing crashes. What are the factors that are actually contributing to crashes? So, number of crash and these factors are related, that is why they are in the SPF, safety performance functions. Statistically they are contributing, right. So, if I tell you or give you some SPF, that will tell you that what are the factors that are actually causing crashes. Second, if you have such kind of functions, then they can also be used to predict crash frequencies. So, I can tell what values of all those factors in a given context means what is the expected number of crashes. I can predict, I can forecast, right. So, one way such kind of safety performance functions, which are you can develop count data models, they can help us to identify the factors which are causing crashes, but at the other side or on the other hand, they can also help us to do predictions given scenario or given certain conditions. I would be able to predict. That is the crash frequency. I can also try to model crash severity, fatal, non-fatal. In this case, you are only making it two groups, and you can easily represent as 0, 1, or it could be fatal, grievous injury, major injury, minor injury, okay, and or fatal, then major injury, minor injury, property damage. You can do more classification, you can make it fatal, non-fatal 2, or you can go for more classes. So, I am trying to model the severity using logical explanatory variables, and because I am trying to model the severity, which normally is expressed like only using 2 levels or 3 levels or 4 levels, something like that. So, here what we developed? We developed ordered model, because your outputs are 0, 1, 2 like that, right. Ordered model we are doing. These ordered models you can develop like ordered probit, ordered logit. If you have taken my course on urban transportation systems planning, there in the context of mode choice model, discrete choice models, I mentioned about logit model, particularly logit, binary logit, multinomial logit I mentioned. Also I indicated what is the difference between the logit and the probit, right. So, here it is basically ordered logit or ordered probit, even other types of model you can also develop. Now, again if you are really interested to do crash data modeling using all these statistical method, probably you have to take a course where you can learn more about the how to develop ordered models, ordered logit, ordered probit, or how to develop the count data model if you are trying to model the crash frequency. But here I can only tell you that yes, you can model crash frequency, you can develop count data models, develop safety performance functions, or you can also develop ordered logit or ordered probit to identify factors which are responsible for severe crashes or which are influencing the severity of crash. Now, this kind of models, ordered models or crash severity models are developed to establish the relationship between the crash severity and the independent variables, which are the causal factors and which are statistically contributing or helping you to explain the variation in the crash severity. Fine. So, if I come to the next slide where I have again summarized the same thing what I saw. So, the statistical modeling or statistical methods when I am applying, I can apply it for crash prediction model, number of crash, all crash together or so, or different types of crashes also, the number I can predict, crash prediction models, or I can use it also for, or I can also analyze the data by developing crash severity models. If you are using crash prediction models, these are the some example models. You can use Poisson models, you can use negative binomial models, or several other non-parametric models. The next part also I will go and discuss little bit. The other way you can use crash severity model. So, there you can use logit model, maybe MNL, ordered logit, nested logit. It depends on how you are formulating, what you want to do, what is the type of data, what you want to do with that model. So, depending on that you can go for logit models, you can go for probit model like MNP or OP, ordered probit or multinomial probit, or even go for other types of model, for example, zero inflated models, right. So, again I am saying I am sorry I have to stop it here, I cannot go into detailed discussion, but if you are interested it is only to tell you yes, if you have the crash data you can try to analyze the crash data and develop models for crash prediction or prediction of the crash severity. You can do that, people have done it, researchers have done it, and several modeling techniques or statistical models can be developed starting from Poisson model, negative binomial, non-parametric models, or if you are doing the crash severity maybe logit model, probit model. It depends on what is your y, what is your x, what is your independent variable, what is your dependent variable, how you are expressing those variables in the database, what you want to do with the model, what you are trying to achieve, and accordingly you have to select a suitable model specification and then try to calibrate the model for the given database. Now, here I am trying to tell you what are the common explanatory variables that have been used in different studies. It is not that everywhere same factors or same variables will come. These are the independent variable or the causal variables you can call, right. Not everywhere the same thing will come. So, I am not saying in your case when you collect data or if you are trying to analyze data, these are the variables that all will become active, or these are the only variables which will become active, or you will find to be statistically actually significantly contributing to explain the variation, may not be, but it gives you some idea. Right. So, you know that researchers have used this kind of variable. So, probably in my case also I should include and I should try to see whether they are contributing, and if you do not find them significant, omit those variables. So, people have used while developing severity model, they have used different road environment related variables. For example, weather condition, lighting, roadway segment and its characteristics, type of shoulder, that these are the different variables. Even human variables, for example, gender, age, use of seat belt, right, use of helmet, use of seat belt, right. Vehicular variables such as type of the vehicle, age of vehicle, and also the crash characterization variable. For example, what is the type of crash, at what time it happened, what day of the week the crash occurred, right. So, when you are trying to model the severity, while trying to model the severity, researchers have used all such kind of variables, which are road environment related variable, human related variable, vehicular related variable and crash characterization related variables. Similarly, frequency models, when they have developed, they have used road environment related variables such as traffic volume, segment length, horizontal alignment, shoulder width, roadway segment characteristics, human variable like the gender, right, crash characterization variable like year, season, right, vehicles involved in crashes, and sometimes some joint models also researchers have developed, frequency and severity models, some kind of together or the joint models. There also they have used very similar kind of variable. You can see traffic volume, shoulder width, speed limit, road width, pavement condition, segment length and also crash characterization variables such as time of the day or day of the week, which day of the week, which time, right, that kind of variable. But these are all indicative. Now, going to soft computing methods, increasingly becoming popular, many cases giving very good results, very promising way, right. So, increasingly researchers are using different machine learning techniques, and you know that it is ML techniques, it is a subdivision of the AI or artificial intelligence and is widely used as a powerful tool for solving problems in various domains. And of course, ML algorithm involves knowledge of various areas, I have mentioned some of those, and several techniques have been developed. So, in transportation, as a transportation researchers, we do not work on developing new techniques, but rather we try to understand these algorithms and then see given my context, what is the whether I can apply, and if I can apply, what are the alternative algorithms that I can try, right, because all algorithms may not work well in all conditions. So, you have to decide, right, what kind of algorithms I will use, and then within that group what are the possible things that can be attempted, and you try many things, and then sometimes some model will give you better performance, sometimes some other model will give you in another context some better performance, but overall very encouraging results are obtained and reported by researchers. So, depending on the input data, whether you have level data or you have some level data, some unleveled data, or whether you have all unleveled data, depending on those you may use either supervised learning, so many algorithms are there under supervised learning. So, you may use supervised learning, you may use unsupervised learning, again so many different algorithms are available, or you can use semi supervised learning, right, and develop models. Here I have indicated that several works have been reported in the literature. Researchers have in various country context, various using different databases, they have actually used ML techniques for modeling the crash severity and also the crash frequency, and while modeling the crash severity, all such kind of things have been used, like starting from random forest to k nearest neighbor to artificial neural network, decision tree, classification and regression tree, right. So, number of things they have used while modeling trying to model the crash severity, and many cases very encouraging results are obtained. Similarly, while trying to model the crash frequency, they have again used deep learning, artificial neural network, right, classification and regression tree. Similarly, support vector machine, number of things they have tried, right. And as I said that it is difficult to tell you a priori which one will exactly work or work better, but this is all you have to see what I am trying to model, what are my independent variables, what are my dependent variables, and or whatever in the overall input data, whether it is level data or unleveled data or some level, some unleveled. So, then decide what kind of learning you want to use, supervised learning, unsupervised learning or so. Then you can think, okay, I have to use supervised learning. So, within supervised learning, what are my possibilities, right, and then try different things and compare the models and see that in a given context what is working in the best possible manner, right, because it is data, it has to be data specific, not that you develop maybe in one case random forest give you very good result, but not every case you will get always the best result using random forest. So, you have to try alternative things which may be tried logically and then see based on comparison that what you are accepting and which model finally you are accepting. So, often in such work we try number of models, statistical model, ML based model, even we compare the performance of different statistical model, different ML based model and then pick up. And in this context the performance metrics is very important, right. So, evaluating the performance of the model is as important as developing them. Now, certain metrics of performance, for example, accuracy, sensitivity, specificity and F measures have been used to evaluate the classifiers in the models, and there are 4 possible situations which can occur in this confusion matrix. One is true positive, that means the example is correctly predicted as belonging to a positive class. So, example is correctly predicted as belonging to a positive class, that is true positive. False positive means it is not true positive, it is false positive. That means, the example is predicted as belonging to positive class, it is false positive, it is predicted belonging to positive class, but actually belongs to negative class. So, that is why we are calling it false positive. Similarly, it could be true negative, that means the example is correctly predicted as belonging to the negative class. It may be false negative, that means the example is predicted as belonging to negative class, because false negative, prediction is negative, but that is false. So, actually it belongs to the positive one. So, the example is predicted as belonging to negative class, but actually belongs to the positive one. And here I have shown you, I have told here accuracy, sensitivity, specificity, F measure. So, A, R, S, F measure, how you can calculate. Using this true positive, false positive, true negative, false negative, right. So, that is what I have explained. So, with this I would like to summarize that what we discussed here, the representation of the crash data using several important basic parameters, multiple parameters we discussed, basic parameters, took some example problem also to show you, one example problem we took to show you different situation, different period, volume, length, but still how we can compare them meaningfully. Then talked about the crash data modeling, said that you may use statistical methods or use soft computing methods for doing the crash data modeling, what kind of models you want to develop, what you want to predict. You may predict the severity, you may predict the number of crashes, right. So, depending on that, what are the, if you are using statistical methods, then what are the approaches, what are the alternatives that are available, and in soft computing methods also, particularly the ML techniques, I indicated also what all have been attempted by different researchers while trying to model the crash severity as well as the crash frequency. So, with this I close this lecture. Thank you so much.